In this video, we will do unknown B, which corresponds to page 5 and 6 of the qualitative analysis lab. And we are going to be following the flow chart. With this, I have a test tube, which I have right here. You can see that very well, but it's a clear solution. And it either has silver, barium, or zinc, or silver and barium, silver and zinc, barium or zinc, or all three ions, or none of these. So 0, 1, 2, or 3 of these ions are present. You're going to determine which ones are present and which ones are not. I'm going to follow the flow chart on page 4 to do this. So I'm going to add Cl minus and mix. And if there is a precipitate, I'll centrifuge and decant. And then I'll take the solution and I will add FeCN6 minus 4 and I'll mix it. And again, if there is a precipitate, I'll centrifuge and decant the solution. And then I would add CrO4 minus 2 to the solution in that last step. All right, so there is going to be an unknown number 1, and you're going to put what is for what we'll call unknown number 1. You're going to be doing 2 in total. You're going to call this letter B, and this both page 5 and 6 are both the same. You put your unknown number there, and then for AG, yes or no with supporting evidence. For BA plus 2, yes or no with supporting evidence. And ZN plus 2, yes or no with supporting evidence. Watch the general video for unknowns, which gives you more specifics about answering that. You need to watch that piece. All right, I'm going to stop my screen share so you can see this a little bit more closely. And here is unknown B, and I'm going to add the first thing, which is Cl minus. You can watch what happens to this. I put 10 drops in. I think you can see that getting cloudy. I'm going to pair that to a clear solution that I have here. So the one that I added Cl minus 2 is this one that I'm moving in my hand compared to a Cl minus. That would be clear. So definite cloudiness. I'm just going to wrap that around or mix that up. And then I'm going to put it in the centrifuge, which I don't know if you can see here. Get that a little bit closer. I have another test tube in there so it's balanced. And I'm going to give that a spin. And that thing spins around at probably 500, maybe even 1,000 revolutions per minute. The heavier things go to the outside. So if you went on a ride that spins at Valley Fair, you're going to be going to the outside with a centrifugal force. And that way we could separate the precipitate and whatever ions are in there in that solid from the rest of the solution. And I'm just going to try to make sure I get all of that out. So I'm talking a little extra long. I want to spin that pretty good. And then I'm going to go to this next piece right here. Okay, so I'm going to slow this down, making sure my hands don't come near where that test tube is. And let's see how that spun out. Pretty good. Okay, sometimes it doesn't, it's really cloudy and it's hard to tell. There's a little haze there, but most of it's on the glass. That should be pretty good. And there's definitely a solid stuck to the bottom. So I have some rinse clean test tubes. I'm going to transfer the solution to this. And notice there's a little haze that goes with it, but it still is quite clear. And I think we'll be able to distinguish whether we're getting reactions or not in the next step. And then here was the solid left behind, and I'll just put that right here. So the next step is to add FeCN6 minus 4. And probably watch most importantly is as I add the drops, what's happening. Okay, so to me, it's hazy, but it looks like it was getting significantly more cloudy as I added the drops, which would be a sign of precipitate formation. So again, I'm going to put this here, and I'm going to put this into our centrifuge and give that a spin. I like to mix it good. And again, sometimes the centrifuges separate it, sometimes not. So then you have to remix and try again. Hopefully that's going to spin it so it separates pretty well. that was the FeCN 6 minus 4, which was the second thing that I added to this. I'm just going to let that go a little bit more. Hopefully this comes out. I don't like to take too long, but I like to make sure it does have time to separate so we don't have to redo it again. It's really important to mix it too so it separates. Sometimes you do everything right and it just doesn't seem to separate like you want. This one is separated. It's kind of hazy yet, and I think we're okay to go with it. I'd prefer to get more of that haze out, but I think we did as good as we can do, and we'll still be able to tell from our next step. So we got that haze, but there's definitely a solid on the bottom. Don't know if you can see that. And probably even a bigger hint was as I added the drops, significant cloudiness. Now I could recentrifuge. Sometimes I can even skim off the liquid and recentrifuge it because that's looking, it might look pretty cloudy on the mirror. It's hazy. It's not so bad from this view. When I add CrO4, I should be able to see it. This is a really clear-cut test if it's present. It should get cloudy right away as I add the drops, more cloudy. So as I add the drops, it's getting yellow, and there's haze there, but it's not really additional haze. It's just the haze that I had there from before. Okay, so I would say when I'm adding CrO4, it's not giving me any additional cloudiness to this. And you might be able to see that in line, you might not. It's pretty, I'll say pretty clear from here that the CrO4 did not add to the cloudiness that carried over a little bit. All right, so that is all the information you need from unknown B. Make sure to watch the general unknown video if you're unsure with things, and let me know if you have any questions. Thanks for watching.